Hi guys, welcome to my All for Science channel, and the topic for today's video is that is a concern for many scientists since the fuel that is used for generating power in nuclear plants can easily get stolen or be diverted into the hands of wrong people who are looking to make nuclear weapons. At the same time, you cannot ask all the countries of the world to stop generating nuclear power since nuclear is the future. Nuclear energy is the only viable major alternative to carbon-based energy, and more such nuclear plants would definitely be required in the future to shift away from fossil fuels. In such a situation, it's very important to prevent nuclear proliferation since rogue groups can easily get their hands on nuclear materials from the core of nuclear reactors. Most traditional nuclear power plants today use pressurized water reactors, which operate on an 18 to 24 month cycle. During the life cycle, the reactor starts with uranium-235 fission, but then it gradually shifts to plutonium-239 fission due to absorption of neutrons by uranium-238. This plutonium-239 is what's dangerous since it can be enriched and used in nuclear weapons. After every life cycle, the reactor needs to refuel itself with nuclear material, and this is usually done under the observation of an inspector who basically ensures that there is no stealing or diversion of nuclear fuel. However, with more unconventional and innovative reactors being invented, like sodium-cooled reactors and small modular reactors, it becomes increasingly difficult to keep tabs on what is happening with the fuel in the reactor core. Reactors in future will have very long life cycles and may not require refueling at all. And in such cases, simple manual inspection during refueling will also not help. This problem is being addressed by researchers at the Georgia Institute of Technology. They have used above-ground antineutrino detectors to record any reactor power or fuel changes, possibly indicating diversion of irradiated nuclear material. Now, what are antineutrinos? Antineutrinos are the antiparticles of neutrinos. The antineutrino is an elementary subatomic particle having infinitesimal mass and no electric charge. In the reactor core, these are produced by negative beta decay, wherein the neutron is converted into a proton, an electron, and an antineutrino. A reactor generates ample quantities of these antineutrinos, and hence a distinct antineutrino signature can be observed using an above-ground detector. However, antineutrinos are highly penetrating particles and hardly interact with anything. That is why they are very difficult to detect. But there is a small chance that antineutrinos may react with protons and undergo a reaction called the inverse beta decay. In an inverse beta decay, only antineutrinos with energy above the threshold of 1.8 mega electron volt can cause interactions with the protons, producing positrons and neutrons. Positrons and neutrons, on the other hand, are easily detectable with standard technologies. This is the basis of an antineutrino detector, and it helps to provide the antineutrino spectrum of the fuel. The antineutrino signature obtained from the detector is then compared with the expected signature of the fuel isotopes undergoing fission. This reference signature is generated using high-fidelity computer simulations for that particular reactor, its initial fuel and burnup. If both the signatures sufficiently match, then it can be said that there has been no diversion. But if they don't match, then the reactor fuel has been definitely tampered with and indicates that diversion has taken place. This technique has been smartly termed reactor evaluation through inspection of near-field antineutrinos, or in short, retina, because the detection principle is similar to the concept of retinal scans used for identity verification. The retina system offers an unobtrusive and unfalsifiable way of checking whether a reactor core has been disturbed. The next step for the team working on this is to make the antineutrino detectors smaller so that they can be carried around easily, and also improving the directionality of the detector so that it picks up the small changes in the antineutrino signature from the core. Nuclear energy in the near future must be accessible to all, but in the wrong hands can also be disastrous to mankind. This technique is a nifty tool developed by scientists to ensure that nuclear power is utilized only for the correct purpose. Thank you for watching this video, and if you have liked it and found something informative, please do like, share and subscribe. Until we meet in our next video, keep learning, keep spreading what you know. Take care and bye-bye.